Hello students, welcome to the subject Design Pattern, course code SCD304. Today we will study Strategy Design Pattern. It's a behavioral design pattern. In today's session, we will start with the intent of Strategy Design Pattern, then we will get the brief introduction. We will try to understand by exploring different examples. Then we will see the participant classes, UML representation, and the code implementation of any particular scenario, and then at the end conclusion. After learning strategy design pattern, it will enable you to design multiple algorithms, multiple solutions for a problem solving, and it will enable you to choose any strategy with different time and space trade-off. It means when you have multiple solutions for a particular problem, then you can choose any strategy or any solution at runtime depend upon the context, depend upon the requirements of memory, depend upon the requirements of time. So you can choose any particular scenario, any particular solution to solve that problem by finalizing any concrete strategy. Strategy design pattern lets you to define a family of algorithms. Family of algorithm means multiple algorithms, encapsulate each one and make them interchangeable. It means to solve any particular problem, you have multiple algorithms, you have multiple solutions. For example, if you have to print or you have to sort the numeric data, then you can use a different kind of logics. You can use if else if, you can use switch, or you can use a cursive solution. So sometimes to solve any particular problem, you have multiple ways or multiple solutions. So consider a particular solution as an algorithm. So you have multiple algorithms or family of algorithms. Then you have to encapsulate each one inside a different class and make them interchangeable. It means the client or the user can select or choose any algorithm for execution at runtime. For example, if you have multiple solution for sorting numeric data, then you can choose the sorting technique at runtime, depend upon the space and the time constraints. So strategy lets the algorithm vary independently from the clients that use it. Strategy is basically the behavioral design pattern uh, that lets you define the family of algorithms and put each of them into separate classes and make their objects interchangeable. So this pattern suggests that you take a class that does something specific in a lot of different ways and extract all of these algorithms into separate classes called strategies. It means you have multiple strategies to solve any problem, to accomplish any task. Strategy design pattern is also known as policy design pattern. It is a behavioral design pattern that enables an algorithm behavior to be selected or chosen at runtime. There are more common situations when classes differ only in their behavior. For above cases, a good idea is to isolate the algorithms in separate classes in order to have the ability to select different algorithms at different times. You have been practicing that sometime you implement different algorithms inside different functions. For example, if you have four or five different ways to perform any task, let's say you have five different functions to perform sorting for numeric data, then you use the conditional statements. So the strategy eliminates the conditional statements. It offers an alternative to conditional statements for selecting the desired behavior or the algorithm at runtime. When different behaviors are combined into one classes as different functions, it's hard to avoid using the conditional statements to select the right behavior or right algorithm for execution. So, encapsulating the behavior in separate strategy classes eliminate these conditional statements. To understand strategy and the policy pattern, I have given few examples from the real world. Many of you have seen a very famous cartoon of Tom and Jerry. You can see that in each episode, in each session, the main purpose and the objective of Tom is to catch the Jerry, and he adapts different policies, different strategies. He makes different strategies to trap the Jerry. So basically, he designed different strategies, different policies, and choose the right behavior at runtime. So it means the Tom uses different strategies, different ways to catch or to capture the Jerry. Similarly, we will define the families of algorithm inside our code, inside our program when we have multiple solutions for solving a problem, and we will let the algorithm to be selected at runtime by the client. Here is another example, another real-time example of strategy design pattern. Let's say a person have to travel from house to airport, and the mode of transportation he uses can be different. He have multiple options. He can travel using public transport. He can use or drive his personal vehicle, or he can use bicycle, or he can use cream or any other services. So the mode of transportations are basically the different options, different policies, different strategies which he can adopt to accomplish his main goal. So similarly, the same role is using the different strategies, different algorithm to be selected at runtime. Let's say you are designing a web application or a mobile application of some e-commerce system, and you have to provide the purchasing online purchasing services, and for this you have to also provide the online payment system. Sometimes the user or the client requires multiple options for online payment, such as he may facilitate the user via paying through the credit card or through the debit card or cash on delivery or any online banking way. So to provide and to facilitate all those payment methods inside your application, you can use the strategy design pattern, and you can write the different algorithms for different payments inside different classes, and user can choose any payment method at runtime depend upon its ease. For example, if he has debit card, he can pay via debit card, or if he wants to pay after receiving it, then he can choose the cash on delivery. So here we have multiple policies for payment methods. Similarly, another application of compressing different files. For example, when you want to send a file over the network, then sometime there is a limit of size, and you need to compress your data, you need to compress your file, and to perform this compressing operation, you can use zip or you can use rar. So which software you are going to use, basically different based on different algorithms, different policies. So here you are all again having different options, different policies to accomplish the compressing functionality. Another good example of using the strategy design pattern is for writing an application or designing an application which performs sorting. You know that there are many different ways, there are 20 plus different ways to sort the data. So you can define the multiple sorting algorithm using the strategy design pattern. Inside each algorithm, you can define the particular logic of that sort. For example, let's say we have numeric data, and we are having three sorting algorithms such as insertion sort, selection sort, and bubble sort. And we want the user to choose any sort uh, at runtime. So we will, or uh, we can implement this scenario using the strategy design pattern. Similarly, in many applications, searching is required, and you know that for searching any particular element from a data, you have different algorithms, you have different logics. For instance, let's take you have two ways to search. One is linear search, and the second is binary search. You know that linear search is a sequential search and is searched by line, so its algorithm will be different. Similarly, the binary search, it will divide the table, the data into two different parts, and it will search in different parts. So you can write the different algorithms of searching using the strategy design pattern. This is the general human representation of strategy design pattern. You can see that we have the strategy interface. This interface basically defines that how all strategies should be configured. It doesn't define the algorithm, but it provides the signature. The strategy class does something specific in different ways, and the different ways can be put using different algorithm into separate classes called concrete strategies. So if you have multiple ways to solve any particular problem, then you will have to write the concrete strategy for each different way. Let's say you have five algorithm for any task, then you have to write the five concrete strategies. Whereas the context is class which have reference of the strategy. It must have a field for storing a reference to one of the strategy. The context delegates the work to a link strategy object instead of executing its own. So the context is not responsible for selecting any appropriate algorithm for the job. Instead, the client passes the desired strategy to the context. It means the client defines the context. So the context doesn't know that how much strategies exist. It works with all strategies through the same generic interface, which is the strategy interface, which exposes a single method for triggering the algorithm execution. This way, the context becomes independent of concrete strategies, so you can add new algorithm or modify existing ones without changing the code of context or other strategies. Here are the description of participant classes, as we have seen in UML. The strategy interface defines an interface common to all supported algorithms. Context uses this interface to call the algorithm defined by a concrete strategy. The concrete strategy is basically concrete algorithm which have logic to solve any particular problem. Whereas the context class contains the reference to a strategy object. Using the context class, the client can pass the mode of strategy or the mode of algorithm. If he wants to change the algorithm, then he will send the request to the context class. To understand the coding implementation of strategy design pattern, we have taken the example of sorting problem. Let's say we want to sort the data, and for performing the sorting operations, we have three different logics, we have three different policies, three different algorithms. One is bubble sort, second is quick sort, third is selection sort. It means we have three different strategies, or we have three different algorithms for sorting purpose. And we can set the type of algorithm, the type of sorting which we want to execute using the context class. So the basic UML representation will be this way, that we have to firstly design the generic interface for strategy, which is strategy interface. It will define the default behavior or the default functionality for all strategies. So inside this we have the signature of a sorting method, and then all the possible algorithms, the possible methods will be the concrete strategies. So the bubble sort, quick sort, section sort will be three different classes, and they will be inherited from the main strategy interface. See what we are doing here, that instead of writing the different three functions for bubble sort, quick sort, section sort, which you might be used to practice, we have encapsulated each sorting logic in different class. And we will use the context class to choose any kind of sorting at runtime. This is the first interface of strategy, where there is a sort method. The signature of the sort method is showing that it's taking the input of numeric data. The first concrete strategy is the bubble sort class, which is implementing the main strategy interface. Inside the bubble sort algorithm, the function sort will be defined. You have to write the whole logic of bubble sorting inside this method. But for keeping track of output, we are using the SOP or just the printing. So the logic of bubble sorting will be inside of the sorting function. It will take the input data in the form of numbers variable and perform the sorting operation on this data. Similarly, the second insertion sort algorithm will be also encapsulated in second concrete strategy, which will implementing the main strategy interface, and it's also providing the same sorting method. The logic, the algorithm, the steps of insertion sort will be inside this method. Similarly, the third sorting class will be the third concrete strategy, which will also implement the strategy interface, and the logic of the algorithm of quick sort will be inside the sorting functions. So you can see that here we have written the three concrete strategies for performing the bubble insertion and quick sort. If you have the further more sorting options, then you can write the different strategies, different concrete classes for them also. Now you can see that inside the context class, there is a reference of strategy. This strategy interface is basically will be set by the client. Inside the constructor, the strategy will be passed, and you can see that there is a generic method of arrange. The arrange will be the method which will pass the data to the concrete strategies, and it will execute the sorting operation with the reference of the strategy. It means at runtime, if you are passing the type of strategy as bubble sort, then it will perform its sorting operation. If you are changing the reference of strategy, so its behavior will be changed. So you can see that we have interchange behavior of algorithms as we claimed in intent of the strategy design pattern. As you can see that inside the arrange method, the strategy is calling the sort method. So the type of strategy will call the specific type of sorting. If the type of strategy is insertion, it will call its concrete method. Similarly, for the other concrete strategies. To check the functionality, working functionality of strategy design pattern, we have defined the main class, the main demo application. In this, you have seen that we have taken the variable of numeric data from 1 to 5 numbers, and to perform the sorting operation, firstly we are creating the context CTX variable, and inside its constructor we are passing the type of strategy. You can see that inside the constructor of context we are taking the input of strategy type. So inside this constructor we are passing the type of bubble sort, whereas in the next statement you are seeing that ctx.arrange method is called. So basically the ctx.arrange will call the bubble sort sorting method. So this is basically the polymorphic behavior of strategy. If you want to change the type of the algorithm, instead of using the bubble sort, you want to use the quick sort, you have to simply pass the type of that strategy inside the context method or context constructor. As you can see in the next statement that the next or the new context is with the type of quick sort. So you can pass the type of strategies and you can change the context of sorting. The specific sorting will be performed based on the reference of strategy which we are passing through the context constructor. This output shows that using the same context class by changing the reference of strategy, the corresponding algorithm is being executed. At the first, you can see that the same array is being sorted using the bubble sort strategy. In the second, you have changed the context with the quick sort strategy, so the particular algorithm will be executed. A family of algorithms can be defined as a class hierarchy and can be used interchangeably using the strategy design pattern. And we can alter the behavior without changing even its structure. So by encapsulating the algorithm separately, new algorithms complying with the same interface can be easily introduced. So the application can switch strategies at runtime depend upon the request from the client. The client will pass a reference of strategy through the context class. So a strategy patterns enables the client to choose the required algorithm without using even the switch statement or the series of if else if statements. You know, it's not a good practice to use the series of conditional statements. and the data structure used for implementing the algorithms are completely encapsulated inside the concrete strategy classes. Therefore, the implementation of an algorithm can be changed without affecting the context class. So you can see that by using the strategy design pattern, you are able to define multiple policies, multiple algorithms to solve a task, and the client can adapt any policy, any strategy based on the runtime context.